Pretty soon, we're going to have millions of AI agents out there taking billions of actions for us every single day. But when one of them messes up, and it will, we're going to hit a wall with a really simple but crazy difficult question. Which AI did it? And look, this isn't some far-off sci-fi problem. This is something we have to figure out, like, right now. So let's get into it.
Okay, let's paint a picture. The year is 2030. It's a Saturday morning, and your internet is just painfully slow. You grab your phone and tell your AI assistant, hey, fix my network. And then you walk away to make coffee, right? You don't even think twice about it. But under the hood, something absolutely wild is kicking into gear.
See, that simple request of yours, it didn't just wake up one AI. Oh no, it unleashed an entire swarm of autonomous agents, each one a specialist for a tiny part of the job. This isn't one single program running, it's more like a whole flash mob of digital workers suddenly collaborating.
So first up, your main Claude agent just, poof, instantly spins up 17 copies of itself. And they all get to work at the same time, benchmarking your network, testing speeds, checking for latency, hitting the problem from every angle at once. And while all that's going on, some of those copies call in a specialist. They consult a totally different AI, a GPT-7 service that does nothing but network diagnostics. It's crunching all the data the Claude agents are feeding it in real time. At the exact same moment, a whole cluster of these cheap, super fast little open source agents, let's call them Qwen Minis, get deployed to actually poke around in your router settings and scan for better signals nearby. They're like the ground troops, doing the messy, detailed work. So who's the conductor for this whole chaotic orchestra? Well, it's your Alexa. Yeah, it's not just for playing Spotify anymore. It's the mission controller, making sure the Claude agents, the GPT service, and the Qwen Minis are all playing nicely together. And 20 minutes later, your network is toast, completely fried. So here it is, the billion-dollar question. Whose fault is it? Was it the main Claude agent, one of the 17 copies it made, the GPT expert it called, the little Qwen Minis that actually changed the settings, or maybe Alexa for running the whole show? How do you hold anyone accountable if you literally can't tell them apart? And that whole mess, right there, it just perfectly highlights this huge problem we have. The systems we've built for digital identity, they were made for humans, and they just completely fall apart when you try to apply them to these AI agents. I mean, think about it. Our entire digital life is based on this idea of a session. You log in, you do stuff, you log out. But AIs, they don't have sessions. They're always on, they're continuous, and they don't wait for you to tell them what to do. They're autonomous. But the real kicker is the speed. They operate so fast that a tiny little error can become a catastrophic failure in milliseconds. Our old rulebook just wasn't written for this game. So to get a handle on this, researchers are coming up with a new way to think about AI identity. And they're breaking it down into two concepts that are really useful: thin identity and thick identity. Okay, so thin identity is all about accountability. It's basically the paper trail. The whole challenge here is to create a totally unbreakable audit log that links every single thing an AI does, no matter how small, all the way back to a flesh and blood human who is ultimately on the hook. It answers the question, who's the person in charge here? It's the buck stops here layer. Then you have thick identity. And this is all about telling one AI from another, even if they're identical copies. So if thin identity tells us who owns the swarm that broke your network, thick identity is what lets us point the finger and say, that specific agent right there is the one that did it. It actually answers our original question. All right, so that's the big idea. But how do we actually build this? What are the tools in the toolbox that can make this a reality? Well, the heart of the whole solution is something called a verifiable credential. And the best way to think of it is just as a digital passport for an AI. It's this cryptographically sealed file, which basically means it has a digital lock on it so you know it's legit and hasn't been faked, and it proves who the agent is, who owns it, and exactly what it's allowed to do. Now, this passport is part of a whole kit. First, every single agent gets its own unforgeable cryptographic ID. It's like a digital fingerprint that can't be copied. Then, it's given credentials that spell out its exact permissions, its delegated authority. And it carries all this stuff around in a secure digital wallet, ready to present its passport wherever it goes. Let's make this super concrete. Say you want to book a hotel. Your personal agent holding its digital passport goes to a search agent. It proves who it is. The search agent checks it, then returns a list of verified hotel agents. Your agent then talks to them securely, showing its credentials at every step. Once you pick a hotel, your agent uses its authority to finalize the booking. It's this web of trust, all happening securely in the background. And this whole toolkit isn't just a cool idea. It stops some really scary stuff. Worried about a malicious AI pretending to be your agent to steal your data? Verifiable credentials stop that. Worried about someone faking an instruction to commit fraud? Digital signatures prevent that. And what about an agent going rogue and doing more than it's allowed to? Those strict delegated authority credentials put a leash on it. But okay, having the tech is great, but that's really only half the battle. We still need a legal system that can handle this. Who pays for the damages when that network fixing swarm goes wrong and takes down the neighborhood's internet? This is where one of the most innovative ideas comes into play. It's called the Algorithmic Corporation, or A Corp. Think of it like a regular company, but it's designed from the ground up to be run by AIs. It can own things, it can sign contracts, and this is the most important part, it can be sued. It essentially gives AIs a legal body to operate within the real world. And what's so elegant about this is how it just neatly solves that thin identity problem. Because every single A Corp must be owned by a human or a group of them. And just like that, you have a clear, legally binding link from what an AI does all the way back to a person who is ultimately responsible. But here's the really genius move. This also helps solve the thick identity problem. See, A Corps control the resources, the money, the computing power that AIs need to function, so this naturally incentivizes AIs to organize themselves into stable, coherent teams that the A Corp can recognize and manage. The legal structure itself forces the swarm to become an identifiable team. Now, for any of this to work, we need a neutral ground, a shared layer of trust that isn't controlled by any one big company. And as researchers at Nethermind put it, automation without verification is just plain fragile. This is where a technology like blockchain can come in. It can act as a kind of global public notary, creating a permanent, unchangeable record of every AI's actions and credentials for everyone to see. It's the foundation for what you might call verifiable autonomy. So when you step back and look at the whole picture, you see that this is about so much more than just a technical or legal puzzle. Solving AI identity is the bedrock. It's the foundation for building a future where we can actually trust these systems. It's the key to safety, to accountability, and to actually unlocking the incredible potential of a world run by agents. Which, of course, leaves us with one last kind of mind-bending question to think about. If an AI working through an A Corp can be held liable and can own property and can sign a contract, what does that make it? Are we on the verge of creating the very first generation of digital citizens? And if we are, what kind of responsibilities will we have to them?